Welcome to my YouTube channel, A Binary of Civil. Today I am going to solve the fifth assignment of matrix methods of structural analysis. You can see he has given a continuous beam, end A is fixed and B is roller, C is roller. So he has given coordinate, that is he himself has assigned the coordinates. So coordinate 1, coordinate 2, coordinate 3, 4, 5, 6. So there are 6 coordinates. When there are 6 coordinates, we will get 6 by 6 matrix. Stiffness matrix. Clear? We need to calculate degree of static indeterminacy and degree of kinematic indeterminacy in the first question. Degree of static indeterminacy is equal to R minus S. Number of reactions at fixed support is 3. At roller is 1. At roller is 1. So 3 plus 2 is equal to 5. And equilibrium equations available in the analysis are 3. 5 minus 3 is equal to 2. And the degree of kinematic indeterminacy is equal to, there is one rotation, there is one more rotation. So 2. Option D for question number 1. Next question. Identify the unknown displacements and the known force vectors. So he has given this is a beam. So here 1 and here it is 2. The only possible displacements are U1 and U2. And the forces are F1 and F2. So option C for question number 2. Find the stiffness matrix of member AB. So, thoda dhyan se suno. This question is very typical question. Okay. So, the member AB is this much. First of all, whenever we are deriving, we are intended to derive the stiffness matrix. We need to fix the joints and the length of the member is 6 meters. So here this is A and this is B. This is coordinate 2, this is coordinate 3 and this is coordinate 5, this is coordinate 6. Clear? Now we need to apply unit displacement at B. You will get this structure. So here it is 6 EI by L square. Here it is 6 EI by L square. This is downward, this is upward reactions. 12 EI by L cube. 12 EI by L cube. And the degrees of freedom corresponding to 6352. So 6 is vertically upward. Here it is vertically. So this is upward, this is downward. Okay. So 6 is vertically upward. Here also it is vertically upward. Clear? And 5 is vertically upward, but here it is 5 is vertically downward. By using this, you can able to write the matrix. So the matrix is 6, 3, 5, 2. This 6 is degrees of freedom corresponding to 6. So it will be 12 EI by L cube and this will be 6 EI by L square. It will be minus 12 EI by L cube. 6 EI by L square. Okay, so like this you will get 4 by 4 matrix. It is 4 EI by L minus 6 EI by L square, 2 EI by L. It will be 12 EI by L cube minus 6 EI by L square and it is 4 EI by L. Clear? This is the matrix. And by substituting you will get the required values. EI by 18, 1, 3, minus 1, 3. 12 minus 3, 6, 1, minus 3 and it is 12. So this is the corresponding matrix. Answer D for question number 3. Next question. Similarly, you need to calculate stiffness matrix for CD. Actually, it is not CD, it is BC, corresponding to 5241. So, corresponding to 5241, you will get, I am writing matrix, you can solve one over one. 5241, it is 12 EI by L cube, 6 EI by L square, minus 12 EI by L cube, 6 EI by L square. It is 4 EI by L minus 6 EI divided by L square, and it is 2 EI by L. So it is 12 EI by L cube minus 6 EI by L square. It is 4 EI by L. Clear? So this matrix you will get. So and the answer you will get finally it is A for question number 4. Now we need to write assemble stiffness matrices A, B and CD. So we need to assemble both stiffness matrix for AB and BC. So for the answers, so the stiffness matrix it is 6, 3, 5, 2. So actually the stiffness matrix is EI by 18, 1, 3, minus 1, 3, 3, 12, minus 3, 6, minus 1, minus 3, 1, minus 3, 3, 6, minus 1, 12. This is stiffness matrix corresponding to AB. And the stiffness matrix corresponding to BC is the degrees of freedom corresponding to BC are 5 to 4, 1. This will be 8. So here it is 8, 12, minus 8, 12, 12, 24, minus 12, 12, minus 8, minus 12, 8, minus 12, 12, 12, minus 12, 24. So when you assemble these two, so these two has to be added. These two has to be added. So you will get global stiffness matrix. EI by 18, 6, 3, 5, 2, 4, 1. So 1, 3, minus 1, 3, 0, 0. If anything not there, 0, just keep 0. 3, 12, minus 3, 6, 0, 0. And it will be minus 1, minus 3, 9, 9, minus 8, 12. 3, 6, 9, 36, minus 12, 12. 0, 0, minus 8, minus 12, 8, minus 12. 0, 0, 12, 12, minus 12, 24. And the displacement vector corresponding to this is 0, 0, 0, U2, 0, here you can see so this is 0, 0, U2, 0, U1. So you neglect all the rows and columns corresponding to this 0, 0, 0 and this 0. And the columns are corresponding to, you need to exclude, you neglect this one, you neglect this, this, this. The only remaining elements are, you can see here, EI by 18, I am writing in reverse. So he has asked here it is U divided by UK, here PU. So this is reverse. So I can write it is 24, 12, 12, 36. So this is the answer for this. So the answer will be option B for question number 5. Next, coming to question number 6. What is the vector of known forces? What is the vector of known forces? Pk. That is actually the given beam is this much. So this is A and B and it is C. There is coordinate 1, there is coordinate 2. So we will get fixed end moment like this, fixed end moment like this. WL square by 12. So this is W is equal to 5 kilonewton per meter. You will get it is 3.75. Here also 3.75. Now ascending order he asked. So you will get P1 is equal to 3.75. This is minus 3.75 and P2 is equal to 3.75. Ascending order means first P2 and then P1. Option C for question number 6. Next coming to, what will be the rotation at joint B and C? What will be the rotation at joint B and C means, we know P is equal to K delta. P is equal to P2 and P1. We just calculated P2 and P1. It is 3.75 and 3.75. K is equal to EI by 18, 24, 12, 12, 36. And this is U2, U1. So actually, if you will solve this, U1 you will get it is minus 3.375 divided by EI. That is actually it is theta C. And U2 you will get it is 4.5 divided by EI. That is actually it is theta B. Clear? Theta B and theta C. So that is theta B and theta C 4.5 plus and minus. So option D for question number 7. Next, coming to question number 8, 9, 10 are almost interlinked question. So just by using theta B is equal to 4.5 divided by EI and theta C is equal to minus 3.375 divided by EI. So I am analyzing all this by using slope deflection equation. Slope deflection equation is MAB is equal to MFAB plus 2EI by L 2 theta A plus theta B minus 3 delta by L. Clear? Just by using this equation, you will get final end moments. MAB is equal to 1.5 kilonewton meter. MBA is equal to 3 kilonewton meter. MBC is equal to minus 1.125 kilonewton meter. And MCB is equal to 0. And the reaction forces are VA is equal to minus 0.75 kilonewton and VB is equal to 8.625 kilonewton and VC is equal to 7.125 kilonewton. Okay. So reaction at B is 8.65. The nearest answer is option C. And coming to 7.125. So 7.25. Option A for question number 10. And coming to question number 8. So the proper answer is option D for question number 8. Okay. So this is the most toughest part of matrix methods of structural analysis. To clear NPTEL exam, you need to practice all the assignments that I have explained earlier, and you can find the description below. Thank you.